question number 1. Okay, we're looking for number of moles, which is little n. Okay, we're looking for water. Okay, and guys, these 4 are exactly how they're going to look on your test. Okay, I don't give you the name, I don't give you the formula, I give you the name. Okay, water, well, that's an easy one. Okay, so to calculate molar mass, we have water, H2O. Okay, so that's going to be 1.01 times 2 plus 16, which is 18.02 grams per mole. Okay, so we got our molar mass there, and we're told that the mass of the water we're dealing with is 65 grams. So n equals little m over big M. We just have to substitute in our numbers. 65 divided by 18.02. Okay, 3.61. Okay, 3.61 moles. All right, so 1 mark there, 1 mark for substitution, 1 mark for molar mass. Okay, questions on that one? All right, how many people have done number 2? Okay, let's go over that one too then. Okay, so for number 2 here, we're looking for the mass of something. So we got M is the question mark. They tell us the number of moles, 8 moles. Okay, and it's magnesium chlorides. So what do I need to remember about magnesium chloride? What kind of compound is it? Ionic, all right. So I have Mg, 2 plus, chlorine, minus 1. Okay, so that's going to be MgCl2. If I forget to swap and drop, I am not going to get this next part right. Okay, so magnesium is 24.31. Okay, there's only 1 of it, but I've got to add that to 35.45 times 2. Okay, and honestly, guys, I have put questions like that on unit exams before, and I get a significant percentage of people forgetting to do the swap and drop, thus getting the question wrong. Okay, that's the easiest part of the question. Okay, we got to make sure we're getting that part of it right. Okay, so we got 24.31 plus 35.45 times 2. Okay, so 95.21 is our molar mass. Grams per mole. Okay, so I'm looking for M, which does mean I have to manipulate the mole equation. Okay, to get little m by itself, I need to move big M. To move it, I do the opposite. And what I do to one side, I do to the other. Okay, m times n equals little m. Right, so when we plug in our numbers, 95.21 times 8. Okay, 761.68 grams. All right, so 1 mark for that, 1 mark for substitution, 1 mark for manipulation, 1 mark for molar mass. Okay, questions on that one? How many people have done number 3? Okay, let's have a look at it too then. Okay, that's all right, we'll wait for number 4. Okay, so how many molecules of sodium sulfide are in 200 grams? All right, I saw the word molecules. What am I going to have to use? Avogadro's number. Okay, so I need, or what I'm given is the material, sodium sulfide, which is ionic, plus 1, minus 2, so I've got Na2S for my formula. So we'll have 22.99 times 2 plus 32.06. Or is it 07? 07 on yours? Okay. 32.07, and there's only 1 of it. Okay? So our molar mass, 22.99 times 2 plus 32.07, 78.05. All right, so I've got big M. They also tell me the mass, 200 grams. All right. If I want to find number of molecules, I first need to know the number of moles. Okay, that way I can multiply by Avogadro's number to get the number of molecules. So I've got to go 200, the mass, divided by the molar mass, 78.05. divided by 78.05. So we're looking at 2.562 moles here with all the decimals, and we would of course keep all of those. We talked about that yesterday. Keep all of those decimals. I'm not going to write them all down here. Okay, so this is moles. Okay, and I'm going to multiply that by Avogadro's number to get the number of molecules. Okay, so we have 2.562 ... Okay, times Avogadro's number, 6.02 times 10 to the 23. Okay, so now I just go in here and go times, and it keeps my answer with all the decimal places. Whoop. There we go, 6.02, 23. All right, so I've got 1.54 times 10 to the 24 molecules. Okay, so 1 mark for that, 1 mark for the mole thing, 1 mark for substitution here, 1 mark for molar mass, 4 marks. All right, I'll give you a few more minutes on number 4. We'll go over number 4, and then I'll talk about your toxin projects too. Okay, so this is our 5-mark style question, okay, because it's got the most work to do. They tell us first off the number of molecules. All right, our number of molecules is 1.2 times 10 to the 25. Okay, and they're told, they tell us what material it is. It is iron 2 nitrate. Okay, so this is a 2 plus. That's what the Roman numeral tells us. This is a -1. So when we drop and swap, we require brackets, okay, with a 2 outside of the brackets. Okay, so now we can go 55.85 plus 2 times 14.01, because this 2 applies to everything in the brackets, plus 6 times 16 for our oxygens. All right, so we got 55.85 plus 28.02, our 2 nitrogens, plus 16 times 6, okay, is 179.87 grams per mole. All right, if I'm going to find mass, little m, I need n, and I don't have it. But I can find it because I was given the number of molecules. N is going to be the number of molecules divided by the number of molecules in 1 mole, otherwise known as Avogadro's number. Okay, so we'll have our brackets here, 1.2 E25 divided by Avogadro's number. Okay, so we've got 19 moles, 19.93. Okay, I'm keeping all those decimals. I'm not getting rid of those at any point here. Okay, now I want to calculate what m is. All right, so little m, okay, sorry, n is going to equal little m over big M, so we got to multiply both sides by big M. Okay, and that's going to give us our 19.93, okay, n, multiplied by big M, 179.87. So take that and multiply by 179.87. All right, so we're going to have 3,585, 3585.44. grams. 1 mark for the answer, 1 mark for substitution, 1 mark for the Avogadro, okay, 1 mark for manipulation here, and 1 mark for molar mass up top. Question? Yes, I rounded to 2 decimal places. Oh, was it 8? Sorry, I didn't even look that close. Yeah, sorry, 4 or 5. I just in a hurry. Okay. Questions there, guys? All right, so you know what to expect for Monday. All right,